All right, guys, good morning. So we are going to finish off your notes from last class. So it's a new sheet, but it's the same basic topics. So last class, we went over 4 of the function families. So we're going to just review those, and then we're going to add 2 more. So you'll have a total of 6 function families that you should know. And then we'll add domain and range in with that. So let's start off with the linear family. Put y equals mx plus b. Remember that the parent function is y equals x. And I forgot to put a grid on this, but remember that the y equals x is a straight line uphill, and it should hit perfectly corner to corner. So if you had the boxes, you would have to be a little more specific, but we don't. So just kind of draw it in like that. Okay? Yes. Yeah, I do. Okay, then from there, I want you to think back to when you were in Algebra 1, Algebra 2. Okay, domain, you're measuring all of the possible what? X's or Y's? Okay, domain is going to be all of your possible X values. And you're going to be measuring on the graph left to right. Versus for range, it's going to be all possible Y values, and you're going to be measuring lowest to highest. So for example, if I'm looking at my domain, I want to go how far to the left does the line go? Then how far to the right does the line go? Okay, but remember, it's a line. And actually, if I could have y'all put Chromebooks up just real quick, I see no one's on them, but if you'll just close it. Okay, so to the left, this keeps going and going and going. To the right, same thing. Then for your domain, you would put all real numbers or negative infinity to positive infinity. Now for your range, remember we're measuring lowest to highest. Okay, but what's the lowest that this goes? Well, if it's got an arrow, it goes all the way down to what? Negative. Okay, and the highest is going to be what? Infinity. Positive infinity. Okay, so your domain and range for that are basically the same. Okay, right next to it, you'll see the absolute value family. So y equals absolute value x. And then does anyone happen to remember the shape of this? It's a letter. V. There's a V, very good. Absolute value is shaped like a V. So you're going to put your dot in the middle. And then remember your V should go perfectly corner to corner because it's your parent graph. So it's going to be here, here, here. And then here, here, here. Now for your domain, if I'm measuring this left to right, because remember, domain is all the x-axis that you care about. How far does it go to the left? Okay, how about to the right? Then your domain is all real numbers or negative infinity to infinity. Okay, so if you want to fill that out down here at the bottom. Okay, but my range is not going to be negative infinity to infinity. And the reason why is when you trace your V, does it go down forever? No, it stops going down here at what number? 0. Very good. So your lowest value is going to be 0. What will my highest value be? Positive infinity. Very good. Okay, then remember that for 0, since I have a dot at that value, I give it a bracket versus infinity will get what? Okay, very good. All right, now before we move on to the next family, I want to just touch on Hooyvuks because we talked about it. Remember that Hooy is a special line where it's y equals a number. And remember that your graph is going to be flat across this way. Versus for a Vux, it'll be x equals a number. And then remember that it'll be straight up and down this way. Okay, so Hoy and Vux, I don't think they come up on your assignment today, but I don't want you to forget those are within the line family because they're straight lines. So we've covered all of our lines, all of our absolute value. Go ahead and turn the page. We have two more families that we talked about last time. We'll start with quadratic. Okay, right, y equals x squared. And then do we remember what letter this one is shaped like? A U is correct. So put your first dot at the center, at the origin, 0, 0. Okay, and then remember your next two dots, you're gonna go 1, 1, 3, 1. So it's up 1 over 1, and then up 3 over 1, so that it'll end up looking like a U. Same thing on the other side, 1, 1, 3, 1. And then draw your U. What will my domain be for this one? I got an arrow on this side and that side. Go ahead, Nate. Okay, very good. Now we could keep putting negative infinity to infinity, but we know that's the same as all real numbers. So let's just bring that R symbol back since it's a little bit shorter. Basically, that means both ways, infinity and negative infinity. For my range, can I put all real numbers? No, what's the lowest your quadratic goes? 0. So it'll be 0 with a bracket to infinity with a parentheses. Okay, last function we talked about last time was the square root family. So if you'll put y equals square root x. Okay, and this is the one that was shaped kind of like a hook, if you remember. So you're going to start at the center, at the origin. And your distances are the same, but this time you're going to hook sideways. So it's going to be up over 1, up over 3. Okay, up over 1 and then up over 3. Okay. When you're done with that, I want you to put your domain and range. Just take a guess. Okay, so how far to the left does this one go? It doesn't go back to negative infinity. It only goes back how far? 0. So it'll be 0 to infinity. And then for my range, it'll be the same. That the leftest it goes is 0. And then the bottom or the lowest it goes is also 0. Okay. But let's notice some commonalities. All of your parent graphs start at the origin. Okay, and then most of them have a domain of all real numbers, really except for this one. Okay. Now, before we get into your two new families, we're going to do just a little bit of practice on this page and review what those graphs are supposed to look like. So let's look at number 1. Also, I designed your notes so that if you want, this is up to you. That first page, you can just pull it off. That way, you're not like flipping through the packet. You'll have all the shapes just on one sheet. Okay. So just rip that top page off. Okay, out of your 4 families, linear, absolute value, quadratic, square root. Okay, what type is number 1? It is linear, very good. That means it's y equals x plus b, very good. Okay, so number 1 is y equals mx plus b. If you want to, you can write linear. Okay, where do I start, with the m or the b? Begin with the b, so it's a -6. So 1, 2, 3, 4, 5, 6. Then from there, remember that the m tells you where to move to get to the next point. Okay, your m is a rise over run. So I'm gonna rise 2, then I'm gonna run 3. So starting at that bottom dot, you're gonna count up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Now, even though my line is in a different spot, think about your domain and your range. Is one side of the line still going to the left and one side going to the right? What about one side going down and one side going up? So what is your domain and range for this line? Still all real numbers. Okay. All right, next one. Take a look at number 2. Look at your little cheat sheet if you need to. Look at the equation and tell me which graph this is going to be shaped like, which family. Okay, those bars mean absolute value, which means it's shaped like a V. Now, last class, we learned that if there's a number in the bars with the X, it shifts your graph left or right. I have a -1. Which way am I going to go?
Right.
To the right is correct. So you're going to go to the right 1 and then up 2. So go to the right 1, up 2. Okay. Then from there, this number in the very front adjusts the slope. So it's a -1/2. That means that I'm going to rise -1 and then I'm going to run 2. So starting at your dot, remember we're making a V. You're going to go down 1 over 2. Down 1 over 2. Then go back to the center and you're going to make the V reach out the other way. So you're going to start back at your starting point and go down 1 over 2 this way. Down 1 over 2 this way. Just like that. Okay, then I want you to think about your domain. Remember, domain is side to side. How far to the left does your V go? Okay, infinity, what about to the right? Infinity, then your domain is all real numbers. Okay, but your range, I want you to think about it in order. We're going to put the lowest it goes, then the highest. Does this V only go down to 0 like the parent function? No, it goes down how far? Forever, never, never down to -infinity, but the highest it goes is how high? 2, very good. So your lowest value is -infinity, your highest value is 2. Okay, then remember, infinity always gets the parentheses, 2 gets a bracket because it actually does hit a height of that. Okay, take a look at number 3. Look at your shapes. Okay, this is a new one that we haven't done in these examples. Is it the U or the hook? Hook is correct. I have a -3, which way are we shifting?
Right.
And +1? Based on the symbol. So if it's a square root, then you'll look on your sheet for where the square root is. It's this one, then you know it's a hook. Okay? Versus if it has a squared on it, it'll be a U. Okay, so go to the right 3 and up 1. 1, 2, 3, 1. And then remember, on your sheet, you can count the boxes to get the shape. It's up over 1, up over 3. So 1, 1, 1, 3. Now your third box kind of ends up off the page, but it's okay. All right. Now, look at the example right next to it. And I want you to tell me what new number is in the equation. From here to here. The 2. Okay, so I want you to pick the same starting point. It's still over 3 and up 1. 1, 2, 3, up 1. Okay, but if you put a 2 in the front, we didn't cover this last time, so I didn't want to do too much on the first day. That's going to stretch your graph so that instead of you only going up 1 each time, you're going to go up how many boxes do you think? Up 2. So watch me do it first, and I'm going to have you do it. Here's my starter dot. I'm going to go up 2 over 1 up 2 over 3. And see how now it's still a hook, but it's a little bit of a steeper hook. Okay, so I'm going to draw the original one in yellow just so you can see the difference. This is where your hook normally would have been. Okay, or actually you can see it right there, but you can tell this one is steeper. So I would like for you to please circle the 2, and I want you to put that this is a vertical stretch. And the reason that it's a vertical stretch is because instead of your dot just being up 1, now it's stretched where you're going to jump by 2. Okay? Now, for both of these graphs, the domain and range are going to be the same. Okay, for the domain, how far to the left does your hook go? 3. How far to the right does it go? Infinity. So put 3 to infinity. Now for the range, remember we're doing lowest to highest. So what is the lowest that my hook reaches? Hello? 1. And how high does it go? All the way till infinity. Okay? But remember that your domain, you're counting an X value, range, you're counting a Y value. I'm going to be lazy and just put same. Okay, if you stretch the graph, it's not going to actually change your domain or range. It's just going to make your hook like steeper. But if it's going up forever, then that doesn't really affect it. Okay, turn the page. Look at your next 2 examples and tell me what they will be shaped like off of your parent function sheet. Okay, it is going to be a U. Very good. So which way are we going if there's a +4 in parentheses? Left and then down. So go left 4, 1, 2, 3, 4, down 1. Do I have a vertical stretch number? No. Can we put that computer away, please, son? Okay, so it's going to be over up 1. And then remember, your next jump is up 3 this time, okay? So 3, 1. And then 1, and then 3. Can you say that again? It's because 2 squared is 4. So you already went up 1 for the first dot, then you go 3 more to get to 4. Because you're counting how many boxes away. So if you do 1 squared, you go up 1. And then if you go over 2 squared, you have to go up 4. That's what it comes from. But that's going to be your parent sheet. Okay, now take a look at the very next question. You'll notice that the translation part is the same. I'm still going to go to the left 4. I'm still going to go down 1, but what do I have that's new? The 2 is going to stretch it. So put your initial dot in the same spot at -4, -1. But this is going to be a vertical stretch on your graph so that instead of you going only up 1 box, you're going to go up 2 boxes. Now, the next jump, do you remember how big it was? It was up 3, right? If we double that, how much is my next jump going to be here? 6. So it'll be 1, 2, 3, 4, 5, 6 will put me up here. Just do your best. Okay? So the 2 in the front is going to double those values, but remember, you're stretching it up vertically. So instead of going up 1 box, we're going up 2. Then instead of going up 3, we're counting up 6. So it essentially doubles both of those values.
For the other one, you went over 4, but this one you only did.
Oh, did I count wrong? Dang it, I did count wrong. Just pretend, okay? I should have gone over 4 boxes and I counted wrong. My bad on that. Okay, but hopefully yours is right. Thank you. Okay, for my domain, does my parabola go left and right forever? Yes. Does it go up and down forever? No. How low does it go? -1. How high does it go? infinity. Very good. Okay, go down to the next one. We're just gonna do, let's do number 7. Okay, I have a +4 and a -1. That's the same. Okay, but this time I'll count it correctly. So it's left 1, 2, 3, 4, down 1. Okay, this time, what is your vertical stretch number? 1/2. Now, if your number is bigger than 1, vertical stretch is the correct term. If it's a smaller than 1 number, you're not going to call it a stretch, you're going to call it a compression. So I want you to circle the 1/2 and put vertical compression. And so here's what that means. Instead of you going up a full box, guess how much of a box you're going to go up? Only half a box. Now, this graph is going to be a little bit harder to do like very accurately, but just do about half a box on both sides. Okay? So just half a box on both sides, because it's going to squish your graph down and compress it. Okay, now for your next dot, it would be 1/2 of 3, which is, does anyone know how much that would be? 1.5. So your next box is going to go here. Now on your delta math, when you move the first dot, it'll automatically adjust the second one. So just know that my 1 full box is now only a 1/2 a box, and this dot will fix itself. Okay? But notice, okay, that your domain and range are not going to change based on how squished or stretched your U is. It's going to still be -1 to infinity for the range, and all real numbers for the, or wait, I said that wrong. All real numbers for the domain, and then -1 to infinity for the range. Now, real quick, I'm not going to do this one, but do you remember what the negative does? It makes it open down, and we're going to cover that again, so I'm just not going to cover it right now. Okay, but remember, this means that it will open down. Lauren, you had a question?
Is the way you tell the, lowest point by the.
It'd be by the y-axis. So see how this is the lowest point and how low is it? But it also is from the -1 equation too. Okay, go ahead and turn the page. Okay, and we are now to.
Why did you separate?
Huh? Just because we've done a bunch of examples. I can do it with you though, since you were absent in a minute. Okay, so go to the next page. Is this one of the families that we already went over? No, because it has a x to the 3, and that's new. So I'm going to draw the parent graph on here, and then we'll work the examples after. So go to your little new thing. Okay, cubic is going to be y equals x cubed. Okay, and put your dot at 0, 0, because we know all the parent functions start at 0, 0. And this one is a little bit of a weird shape. I'm going to call it a squiggle because it doesn't really have a name. Okay, but you're going to go up 1 over 1. And then back 1, down 1. Now, you might be thinking, well, wait, isn't that just a straight line? You're going to connect it with 2 little arms. One arm is going to arch up. The other one is going to arch down. So it's going to end up being a squiggle. You can watch mine arch one side up and the other side down. Okay, so your graph is going to have a little kind of squiggle in the middle, but overall it's very similar to a line. It's going uphill, it goes through the origin, okay, but you want it to make kind of a little bend. Okay, your domain and range are both going to be all real numbers. Okay, and if you think about that, that should make sense because you have one arrow pointed back, one arrow pointed forward. One arm is bent down, the other arm is bent up. So when you're ready, look at your first example on your notes. In that function family, think about which way we're going to shift it. But I want you to remember that just like last class, hopefully you remember I told you, okay, all the rules are the same. So if it's a -2 in the parentheses, which way will you shift? To the right? What about the +1? Up. So go to the right 2 up 1. And then look in the front. Is there a vertical stretch or compression number? No, then your boxes are going to be 1, 1, and 1, 1. So let's do 1 uphill, 1 downhill. And then remember, you're going to do 1 arm up, 1 arm down. So it's going to be up on this side, down on that side. Okay. And then I want you to remember as well that no matter where I move this squiggle, as we're going to call it, okay, is one arm still going down and the other up? And one to the left and one to the right? Then your domain is going to stay all real numbers. It doesn't matter where you put it. It's going to be all real numbers for domain and range. Okay, take a look at number 10. What number is new? The 3. So start at the same starting point. This is to the right 2 and up 1, just like last time. But the big difference is instead of that box only being 1 up and 1 down, how far are we going to put it up and down? 3, because it's stretched. So starting right here, you're going to go up 3 for the next box and down 3 for the next box. And you're still going to try to squiggle it. So it's going to be uphill on one side, downhill on the other. Also, as far as the words go, would this be a stretch or a compression? Stretch, because remember, anything bigger than 1 is a stretch. Vertical stretch. Okay, versus less than 1 would be considered a compression. Okay, let's do the next 2 on this one. Number 11, your starting point is the same. Go to 2, 1. Okay, 2, 1. But what new number is in number 11? 1/2 will be a stretch or a compression? Compression, very good. So for your vertical compression, instead of going up 1 whole box, how much am I going to go up? Only half. So go a half here and then a half here. Now notice, am I still going all the way 1 box to the side? Yeah, because you're only squishing it this way. You're not pulling the dots away. You're only making them taller or shorter, okay? Then draw your little squiggles. So it'll be 1 arm up, 1 arm down. Okay. Last one, take a look at number 12. Put your starter dot down at 2, 1. Okay, because the actual shifting on the equations is the same for all 4. Okay, but this time I have a what? Negative. So instead of me going up 1 on this side, where am I going to go, do you think? Down 1. So put your dot here. And your other side used to be down 1, but now it's going to be up 1. Okay, so you're going to notice that now, instead of your graph being like this, now it's going to be whoosh, like this. Okay, but it's the same thing. 1 arm goes up, 1 arm goes down. Will which arm is up and which arm is down change my all real numbers for my domain and range? No. So if you just want to put same, that's fine. Okay, then we just have the last family type. So if you'll go back to this little parent sheet, try not to lose this since it has all your families on it. And the cubic root is going to be y equals. Then I want you to draw a square root x symbol. But then to make it a cubic root, you're going to put a little 3 in the elbow. Okay, like that. And y'all should have seen cubic roots at least in algebra 2. Now, here's the kind of good thing about cubic roots. Their shape is also a squiggle, but instead of it being a squiggle up and down, it's a squiggle sideways. So put your dot at 0, 0. Put your dots at up 1 and down 1. But when you connect your arms, this arm is going to point up, but to the side, and this one's going to go down to the side. Okay? But remember that when you do these in Delta Math, it's going to pick the right shape for you. You're just going to have to do the stretching and sliding part if you need to do that for the question. Domain and range, what will they be? All real numbers is correct. Okay, so you're on the last page of today's notes, look at number 13. Tell me which direction we should move number 13.
Right.
To the right 4 is correct. So go to the right 4 boxes. So that'll be 1, 2, 3, 4. And now notice that for this one, why do I not move it up or down? There's not a number in that spot, right? It'd have to be this number at the back, and I don't have one. Okay, from there, put a dot here and here, 1 box away up, and then 1 box away down. But then remember, it's just how you connect them that tells which type of squiggle it is. So we want a sideways squiggle. Hi. I do.
Oh, okay. She's one office, the main office.
Right now?
Yes.
Okay, that's okay.
Thank you.
Thanks. Okay, then your domain and range are gonna be what? 1 arm back, 1 arm forward, 1 arm down, 1 arm up. What's it gonna be? For domain and range?
All real.
Correct. Okay, look at the one next to it. I'm still going over 4, but what's my new number?
2.
A 2, so 1, 2, 3, 4. And what do we think that 2 is gonna change? Instead of my up 1, down 1, what am I gonna do? Up. Okay, up 2 on this side, down 2 on this side. Okay, and then remember, it's 1 arm curved up, the other arm curved down. For the next example, I'm just feeling lazy. We're not gonna do it, but how many boxes would you count?
3.
You get it? Yeah? Okay, and then for the last one, what would you do if it's a negative? You would flip it. So let's go ahead and do that one since it's a little bit more new. So the +3, which way are we going? Left 3 and then down 1. And then instead of my squiggle being up on this side, down on this side, I'm just gonna reverse it. So this is gonna be my down side and my up side. Okay, then the graph will look like this. Okay, but remember, when you're on Delta Math, you're only gonna be moving the green dot if you're relocating it, and then the first blue dot, and it'll fix all the rest of the graph. Okay, so when you're ready, will you open up your computer, please? You're gonna log back into deltamath.com. I do. Do you need one? Okay, I'm on the second to last question. Okay, second from the bottom.
I don't know.
Okay, second to last question. Okay, that second question from the bottom. I do. Okay, were y'all able to find this one?
No,
Still
my
loading?
computer decides to get Windows updates.
Okay, and, you log in, or just type in your.
I can't do that.
Is this like an update, or is that your?
Windows computer decides to do Windows.
Okay, that's okay. Maybe someone can let you use their.
It should be done.
Okay, go ahead and take a guess. You have 2 tries, so if you get it right, then you don't even need to wait for it.
Go ahead.
That's the second one from the bottom. Did you do the sign in with Google? Oh, wait, okay. The internet just, it'd be struggling.
How was your weekend?
Oh, it was so great. It was my birthday on Friday.
Oh, happy birthday.
Yeah.
Happy belated birthday.
My husband got me flowers and then 3 new tennis shoes and then we went out to eat.
Oh, where'd y'all go?
Where'd the rodeo go?
I swear.
Rodeo go? What is that?
It's burgers. Well, we went to the one in Rockwall. There's one close to you.
Let me check. Can I go? Let me look this question.
Do it. It's the bomb, honestly. Okay, real quick. Okay, this is second from the bottom. What does the 2 do? Stretch, which dot do I pick? The blue. Now, the blue is gonna be your stretch dot, but listen. Okay, watch me do this. I'm gonna do it wrong, and I want you to tell me what I'm doing wrong. I'm gonna take this blue dot right here, and I'm gonna move it up to 2. Oh wait, that's 3. Okay, why is that gonna count it wrong? I didn't just move it up, I moved it to the side as well. That's not gonna work. So I'm gonna start over. You have to drag that dot straight up. You can't like let it wander off to the side. Then what do I do with the -5?
Shift right.
Green dot to the right. Very good. Your next question is gonna ask you domain and range, but for the whole cubic family, what is it? All real numbers for both. Okay, you got it from there?
Yeah.
If you get one wrong and you want me to reset it, just let me know, okay? Still know me? There, what did you do?
I forgot. I wanted to keep my password.
That's why I'm gonna take it.
Were you able to finish? Okay. Thanks. Lauren, that one on the board is second from the bottom in today's assignment.
It's dry.
So we can go ahead.
Oh, that's what they were.
You can do all of them now.
Flame on.
Yep, flame on.
Yeah, they felt.
How y'all doing over here? How we doing?
This, how you do this?
So go back to your other questions and then just look at the picture though, because they go together. You know what? The domain and range. Mine, yes. So then when you go to that next question, then you know you're picking all real numbers for both.
Never mind. Wait. What? No, I think I'll rent that word.
Okay, so how low does it go?
No, don't do that. I just wanted to show.
Okay. I'm not. I mean, like you could. You know, like you could. Feel so good over here.
Hello, hello. Well, towards fours, I think this one.
Yes.
The low, yeah. The low side, yeah. And now.
Oh, we didn't,
Yeah.
but you look good.
Oh, that's range, right? You know what? Wait, why is it like that?
Why are you?
It's because.
Oh, it's
The range is like, okay, so, you guys, yeah.